So, hello everybody. It's really exciting to be here this evening. I just want to say that we have load shedding, so I'm not sure how the signal is going to go, and I hope the delay is not too bad. But I am really, really excited to be sharing some amazing work with you this evening. So Jasmine Florentine is this incredible young woman who has combines art and robotics and coding and all these incredible things together and does these amazing STEM projects. And I think when you see them, they're the kinds of things that we can really do in our classrooms. So she combines storytelling as well as design and graphics. So Jasmine, I'm so excited to have you here this evening. Welcome. I'm really, really excited for you to share with everybody.
Thank you. Yeah, thank you for having me. And thank you for the really nice introduction. I'm glad I wasn't on camera then, because I get very flustered by compliments and stuff. I gotta get over that. So, oh no, are you frozen? Might be the load shedding happening right now, actually. Well, I am not sure then if Karen's been frozen. And I can't see all of you guys, so I guess I'll just introduce myself in the meantime. So yeah, as Karen said, so my background is actually in mechanical engineering, and I'm also an author and illustrator. My first book is actually a STEM book for kids, and I'll talk about that in a bit. And I am actually going to try and refresh in case this is a problem from my end. So sorry about that. Oh, nope, Karen's gone.
Yeah. Hi, Jasmine. Are you back?
Okay, I wasn't sure if it was from my end or not, so I just thought I would reload just in case.
Oh no, it was our power. So that's the load shedding kicked in. So the Wi-Fi had to sort itself out. So I'm sorry. So sorry, everybody. Thanks for being patient. We're back. So Jasmine, do you want to tell people a bit about your background?
Yeah, so I just started to before I was worried about it being from my end. So I mentioned, so my background is in mechanical engineering. I studied at MIT in the US, and I focused a lot on product design, but while I was in so let me back up. So my focus was on mechanical engineering. I've always loved art, and I've always wanted to combine art and engineering, which is part of what kind of drew me to product design, because product design is it's very creative as well. And then when I was in graduate school, I started to become very interested in STEM education as well. And that kind of came from my own experience, because I fell into engineering almost by lucky accident, because I didn't really know what it was growing up. I wasn't really encouraged to do it. And I realized a lot of kids just didn't have a clear idea of what engineering is. Like when I would go back home and say I was studying mechanical engineering, people would say, oh, so you're building bridges. I'm like, well, no, not actually. So that was around the time that I started writing my book, which I wish I could say that you guys could buy right now, but it got postponed due to COVID. So it'll be coming out next year. And it's called Hexallen and the Clanksmiths. And the idea is to kind of introduce kids to engineering and show how cool it is while the characters go and have this adventure. And then after grad school, I went and worked at First Robotics, which I'm actually wearing a shirt from them right now.
Cool.
Yeah, and they're a really great program, so I'm happy to talk more about them as well. They run robotics competitions for students to get them interested in STEM. And so I was there as a mechanical engineer, but also a visual artist. And then, yeah, I've been moving around a lot the last few years because of my partner's work. And during quarantine, I started really getting into paper robots, because one of the things that I found when I was writing my books and stuff is I was trying to figure out how I can make projects that are accessible to kids without needing like a 3D printer or a machine shop or any specialized equipment. And I was introduced to the microbit which if you don't know about the microbit, it's like this amazing like little chip basically that has all these sensors and stuff built in. And so I started building paper robots at home using that with the intent of having something that kids could like build really easily. And I've got a bunch of them sitting here so I can show those whenever.
That's fantastic. I agree so much on explaining engineering to children. So most of my life, I taught a subject here called design and technology. And that's your basis for teaching children about engineering and getting them to understand the design process, but also what are mechanisms and what are systems and the different kinds of systems and how they fit together. And I think that's really incredible. And I suppose what I like most about what you do is that you take the mechanisms and the systems and you build these cool paper structures. And then you show them, well, they can be coded. They don't have to be driven just with a little battery and a motor, but you can actually now program them. And you make it so accessible, which is exactly what you want. And when we're talking about making people able to access technology from a range of spaces, I think that's what we need. Because yes, we have these incredibly wonderful built robots that have been programmed to do a range of things. But actually, when the children can do it themselves and understand what is a system and what is a structure and how the two work together and how a mechanical system has to be part of the system and then an electrical and electronic system, it just makes it real. So do you want to show us one of your first ones?
Right.
No?
I was just going to say, and the other thing is also like, you know, in terms of robotics in particular, robotics is really, when you boil it down, it's just about inputs, like decision making in terms of the computer and outputs. And like what I like with the paper robots is you kind of boil it down to very simplest thing of like, you know, here, so, okay, I guess I can actually pull one up. So, oh no. So this guy has managed to survive a suitcase ride from Ireland to Israel. So it's looking a little bit worse for the wear. Unfortunately, so the input for this one originally was actually a touch sensor. Because I am using a extension board for this that doesn't allow touch sensing, I've changed the input to just be a button, just because I have a limited number of extension boards on here. But normally what happens is you touch the foot and it waves its arms because it's being tickled.
Is so sweet.
Oh,
so, and then the templates that you use for that, so you design them, so then you look at the boxes, and is there anything else that you put inside the card?
It's just like a printable template that you fold it, and like you can see that you know, even the servos are attached with paper and everything. Like some of them are a little bit more not complicated. So like this guy, for instance.
Oh yes, I love him.
Thank you. And again, normally I had to kind of compromise because I only have so many microbits,
yes,
but normally this one you snap and oh yeah. So this one withdraws the tentacles, and normally it happens when you snap your fingers, but I only have one of the microbit V2, which has the microphone. So this one's a little bit more complicated because it's also got string and straw and cardboard and stuff, but it's still just all materials that you use at home.
And then, say for example, threading your string, do you use a needle and thread, or how do you do that easily?
Yeah, it's just needle and thread. It's almost, because it's funny because I was in lockdown too, so I didn't have access to any kind of specialized tools. So it's sort of like this challenge of, well, if I can't do it, then nobody else can. Or rather, you know, if I can do it at home, that means then like some kid or school with like your resources. Yeah, exactly.
And is it special card, a special thickness, or is it just ordinary sort of A4 sheets of card that you build the templates on?
I've been using cardstock just because it's a little bit thicker and holds its structure better. Okay. I think for some of these regular paper would work. For some, it may not because it, you know, has the weight of the servo itself. But you can just get, you know, cardstock like at most like craft stores or things like that. Yes. Yeah.
And then to hold the server in place, what do you do there? Do you make a paper holder to hold the server? Or what actually holds the server so that it doesn't move? Because that's often a problem for children too.
Yeah. So I know some people actually just glue it down with hot glue, which works. For me, because I'm reusing, especially at the beginning of this, I only had a couple of servos, and so I wanted to reuse them, so I didn't want to actually put glue on them. So I'm mostly just making like little paper holders, basically. So here's another one.
That could make sense at school too, because then children could, like you do, use the same electronic equipment over and over, just in different models.
Yeah, and that's the idea. I mean, the only problem is some of them you have to cut them open again to get the servos out. So like this guy, I can't actually show anymore because I cut it open to take the servo out. But you can see where the servo was being held in there, and it's just this. Can even see kind of the template markings there. So I just glue it down with the thing. Yeah. And I've seen other people do very clever things with attaching servos as well. Like some people use, especially if it doesn't work as well for paper, but if you're using like cardboard or wood, you can use like zip ties or like even, I think people have even used rubber bands to like keep them down.
Yes.
So
yeah. Yeah. And then to join your servos onto the levers, so whatever you're getting to move, what kind of linkage are you doing there, or how are you joining that easily?
Yeah. So it depends on what I'm trying to do. So for some of them, like this one is just attached directly to, like, that's just a servo horn. It's a Lego servo, so it looks a little different.
Okay.
And it's just literally like a little folded box of paper that just slides right on.
Okay.
Yeah, and then
so it's
that
almost
one is
like a straw type system that you're using there.
Yeah, and actually the original one I had actually did use a straw on there. But this kind of the horn was a little too thick for the straw, so I just did paper instead. But then for some of them, if I want like a more complicated mechanism, like if I don't want to attach it directly to the servo, I'll try some other things. So like going back to the octopus again, it's sort of like this piece of straw is holding the strings, which then pull the tentacles, or even this one. Unfortunately I don't have it plugged in, but this is where it starts to get a little more complicated. And this was me like basically trying to translate things like that you use in mechanical engineering to like paper and cardboard. So this one's got like a rubber band going from the servo to these like axles. Sorry, it's really hard to see, but
we can see.
Yeah, so it basically, you've got like a belt drive that uses what do you call them? Barbecue skewers and like rubber bands and stuff. So yeah, for me, a lot of the fun is just trying to figure out like what can you do besides just attaching it directly to the servo.
I agree, because that's where you have the complications. It's that join, and that's also the thing that often gives the trouble in terms of getting the mechanism to work. And then you had gears over there. So do those gears actually move, or those gears, I mean, are they controlling something, or do they move as part of the electric bands? I mean,
yeah, so that's the funny thing is these ones are fake gears. These are just to look cool, because what's actually moving the gears is the rubber bands. And that's
what I thought.
Yeah, the actual gears are like, hard to cut very accurately. So one resource I actually really like is Mech. So that's if you have access to a laser cutter. They provide the files for like a rack and pinion and a couple other things. Wow. And they just laser cut it out of, it's not, I don't actually know exactly what it's called. It's on their website though. It's like a thick cardboard, like a very dense cardboard.
Okay.
Yeah, and it's great because it's all free on their website. Like this full pattern is just what they've provided, and then you can do some really fun things with it. So like, let me turn this guy on. So this guy is sound sensitive. And you can see in the back, it's just this rack and pinion moving up and down. Yeah, and unfortunately, I hid the or I glued over the system, unfortunately, because I've got the popsicle stick. Oh, you can kind of see it from the side, actually. Hold on, maybe
Yes, you can. You
see
can
those
sort of see
gears
the movement.
moving.
Yes.
Yeah, that's fun. And the popsicle stick was because I made a version where you could take the servo off and just move it with your hands, so you don't even need to program anything if it's going to be like a simpler thing. But yeah, I would say I haven't really found a good way to do, or I haven't really experimented as much with doing gears that are like handmade yet. So that's something that's on my to-do list.
Yeah, I think gears are much more complex than using levers. I think it's easier with the levers.
Yeah, I think anything you can like cut out by hand or like make out of popsicle sticks or cardboard winds up being just a lot easier to just cut and make. Whereas gears, they're just such a complicated shape. Like trying to cut all that out is hard.
So the organization which you said that they're from University Colorado Boulder, but how do you spell the paper, Mech, or how do you write it? So how do people?
It's just paper, like the word paper, Mech, MECH.
Okay.
Yeah,
thank you.
papermech.net. And yeah, they've got all the files for cutting the things, as well as some suggestions and some like suggestions on how you can attach the servos and stuff. So that's a really cool resource that I've just really started exploring.
Yeah, that sounds really lovely, because I think often we get stuck because we don't have templates or we're not sure. And if you've got templates, it's always a start. Once you've learned how to do that, you can always do others, but it's a good start.
Oh, yeah. So, speaking of which, oh, sorry.
No, go.
Oh, I was just going to say, speaking of which, pretty much all the paper robots that I showed so far, there are free templates on my website if like people want to just print them and use them. So I've been I've actually been very lucky. I've been getting companies to like kind of sponsor a project, so I have the time to sit and document it all and then like be able to provide the instructions for free. But if anybody makes any of them, I'd love to see. And if you need help or if you have suggestions for improving the instructions to make them just easier, I'd appreciate that also, because I'm still learning what works for kids and what doesn't.
Yeah, so those of you who are watching, hop onto Jasmine's website. It's really, really incredible, all the ideas and things that they've got there. I just wanted to say, you were chatting just now, but David said, my colleagues and I love the Ticklebot. So yes, it was the first one I saw, and I really thought that was gorgeous. So
oh, thank you.
The ideas, where do the ideas come from?
I don't know. I guess I mentioned I'm an illustrator, and so I usually start by just doodling all my ideas down in a notebook, which I unfortunately don't have with me. But it kind of, I mean, so the Ticklebot actually started because I was talking to a maker who makes these incredible wearable robots. His name is Javon Moss, also known as Odd J. And they're like 3D printed and they're really cool. And I saw him give a talk and thought, wow, this is so fantastic. Like kids would love this, but most kids don't have access to a 3D printer. Or if they do, may not know how to use it. So I actually talked with him and we kind of had a back and forth. And I was sort of inspired after that to think about how can I make robots that don't use 3D printing, that just use like paper and stuff. And so basically doodled out a bunch of ideas and then started building them. So yeah, I don't know. And then sometimes the idea also just comes from, oh, I want to try this mechanism. Like, what can I make with this mechanism that's cool?
Yeah, that makes sense in terms of from both points of view. Do you want to talk to why do you think it's beneficial, but also if you think important to consider the art side and the engineering, how the two just actually tie so beautifully together?
Yeah, I mean, it's one of those funny things because I went to engineering school and like for me, art and engineering always seemed like a very natural combination because like they're both making things at the end of the day. It's both like a creative problem solving. But the thing is, like, especially in product design, for instance, if you just get the engineering right, but you don't think about how it looks or how it'll be used, you don't have a good product at the end. So yeah, it's really the full combination of things.
And I think that's where schools often, and even society, we divide the two and we say, no, the one doesn't work with the other. Whereas as you've just said, in reality, they work beautifully together because we like good looking or pretty products. And we want them to be able to work. So you want the two to work together. And I think sometimes we say to children, you're doing art, but you can't go into engineering, or you're doing engineering, don't do art. And so it's having that kind of discussion. And I think just your own background is such a good example from that point of view.
Oh yeah, thank you. And it's actually something that, like, I admit that I've struggled with in more traditional industry engineering, is if I go and apply for a standard engineering job, they don't want the artistic half of my brain. They want the engineering part. Even product design places usually divide it into industrial design and engineering. And it's, I got really lucky when I worked at First Robotics because it's a nonprofit. So like, if you have multiple skills, they want to use them. But yeah, it's something that still, I think, in the workplace, they really need to understand that the two of them, go hand in hand and don't need to have like a wall dividing them.
Yeah, I definitely agree with you that and if we switch both of those skills on in children, just imagine the creativity we could bring out in the students, because they'd have the knowledge of how to build it and they'll be able to add the creative flair. So just like your incredible robots, it's the same kind of thing.
Yeah, and I think at least for some of them, it's probably more fun. Like when I wrote my book, part of the motive for it is like giving a reason why people are building things. The story, the reason is for plot reasons, but like, at the end of the day, all these robots are basically just servos moving, but it's no fun to just have a servo moving.
No.
Like, it doesn't do anything. As soon as you build the robot around it, it tells a story and it becomes a character, and it's just, so much more fun and appealing, I think.
I agree. And then the learning becomes fun because you're ending up with something that's not just the motor turning, but it's actually turning something, which is getting a reaction. And yeah, so I think that's really important. If you had to then think of taking one, if you showed us one of the robots again, and we looked at it, how would you actually give teachers tips in terms of where would they start if they're wanting to do something like this?
Yeah, so I think the first thing I would do, because I'm doing some online tutoring actually with a student with a microbit. So I think first thing is I would probably just introduce the microbit because it's got a lot built in already, and just kind of introducing the whole input and output thing. So one of the first things I have done with a couple of the people I've been tutoring has just been programming it so like if you shake it, like a picture appears on it, or if you like what are some of the other things, if you push a button, you can make different things appear. And then maybe introducing like how you can do simple robots with it. So first, just attaching the servo and getting it to move, which again, it's not super exciting, but like one student, she made it, and then she, I told her, okay, now attach something to the servo horn, like of your own invention. And she put a wheel with a spiral on it and said that she'd made a hypnotizing machine. But then once they figured out like how to move the servo, then something like the TickleBot, it really is just like, folding the thing and gluing it together. And then again, with aluminum foil or conductive tape, then you can kind of have the full like robotics cycle. I don't know if cycle is the right word, but like process of like input programming on the microbit to the output of it moving. But yeah, I mean, that's how I've done it, but I also don't know. I'm sure there's more than one way to teach it. And you could probably just jump right into like one of the robots without going through the basics of the microbit. depending on the kid's age and how patient they are and all that.
And if we took the microbit away, so if the schools perhaps couldn't afford the microbit, but wanted to build the robots, so wanted to get them to move, what tips would you give them to do that?
Yeah, so I think first of all, it depends on if you want to introduce electronics. Like there's lots of stuff you can do just, for a lot cheaper. Just attaching like this motor, which I think was maybe like $1 on Amazon, to a battery pack. I wouldn't make something this complicated necessarily, but let me.
With those
this
legs,
guy's pretty beat up. So yeah, this worked. Oh no. It's a little beat up at this point, so you can see legs keep crashing itself. But something like this you can do for a much lower cost than a microbit, and you can't really introduce the input and output anymore. But I think for a lot of people, at least for me, I'm biased, I'm a mechanical engineer, there's a lot of delight to just...
I'm going to say you can introduce the input and output, because it's your electrical energy coming in, you're getting a reaction, which is the output of the moving of your feet. So your system is just an electrical system, which also has input, process, output. It's just a bit different to where you've added a computer program. So if we look at our curriculum here, the way it's taught, it doesn't include coding, but you include processes with input, process, and output. It's just different. Yeah.
Yeah, I guess I meant input more in terms of like sensors, but you're right. This still teaches like intro circuitry, and you can't even like attach sensors without any kind of control. And then the other thing I was going to say is, if you want to like just introduce sort of the making and the mechanical part, is like just working on mechanisms that are hand driven. So this is just a straw, or like, again, going back to paper mech, this is just, again, hand driven. So like, you're not maybe teaching the programming part, but you're introducing like the mechanical element, because like this kind of crank here is what used to be used on like old steam trains and stuff. And
yeah, and I think that's what's important. In South Africa, we've got a new coding and robotics curriculum that's out for draft at the moment. And when we look at that, they're actually introducing robotics to little children, but without the coding. So just what you're saying in terms of a mechanism, then introducing a simple circuit that then controls it. So it's the electrical system, and eventually they get to adding the coding, which I think is really good, because you're building a base of knowledge, of understanding.
Yeah. Do you know about paper circuits? Just because I was thinking in terms of learning just about the circuits. So I, unfortunately, I don't have the battery here anymore, but they sell like these little LED stickers and copper tape.
Oh, wow.
And so you can learn just like very intro circuits just by like using the copper tape and the stickers and a coin battery to like, learn this is how you turn a light on. This is how a very simple circuit works. And they're just, you can do that with standard LEDs too, but they're just fun because you can really like combine them with art as well by like, if you go to their website, the company is called Chibitronics.
Just say that again.
Chibitronics.
Chibi, okay.
Chibitronics, yeah, and they have a bunch of examples on their website of like even just making like greeting cards that have like the LEDs and stuff. And yeah, that I just think is fun because like it's the focus, my focus is a lot on robotics and stuff, but I've used their stuff and the focus is very much on introducing like circuits and here's how electrons flow and all of that.
Yeah, and I think that's what's important is if we can end up making coding just as boring as children see other subjects. So it's how do we actually make all these new subjects stay interesting and fun? So getting the children to be creative and excited in what they are doing. If we look at your little robots, which is your favorite and why? Do you have a favorite?
Oh, I don't have a favorite. I was particularly pleased with those legs I showed you were once attached to a T-Rex. And that one I just thought was very fun because it, the idea of a robot that can just like walk by itself entirely made of like cardboard and hot glue. But I don't have a single favorite. I like all of them.
So if we think again of looking at, say, for example, your little octopus, the little guy whose legs pull in, doing the circuitry, not circuitry, doing the strings and things and getting that. How do you think you could teach children to do that kind of complex mechanism to attach? And then how did you attach that to the motor?
Yeah, and that's actually one thing that I'm not really certain about, like the tickle butt, I'd say you could probably do with a third grader if you're patient, but something like that, I'm sort of like, I would think you would want to work with older kids just because of like the hand-eye coordination. So I would say something like that I would probably do with old, and also it just requires patience because there's 8 tentacles. Yes. In terms of how it's attached, so it's just this this piece of straw actually holds all the strings and acts as a little miniature pulley basically. And then I popped it right on the axle, and I just put a piece of tape to make the axle a little thicker so that it fits on there. You have to, if you don't have the right size straw, you can I use tape as a filler all the time. The other thing you can do with string is you don't have to attach it like that. So this one, the string goes all the way around and winds up. This one, unfortunately, like I said, I pulled the servo out, but normally what would happen is the ears get pulled down because the string goes down. And in this case, all I did was use, rather than a continuous servo, like a angle servo, and it just is tied to the servo horn and just gets pulled up and down. And that literally, I just knotted it to the servo horn. So yeah, and I think for the octopus, someone on Twitter also used a different kind of attachment, which seemed to work very well. Is he used like one of those circular attachments that go on servos that have a bunch of holes on it, and he just tied the strings to the holes, and that seemed to work for him. So it's, I think the fun thing is there's no one way to do any of these things, and people always figure out some really cool creative way of doing things.
And I suppose that's what creativity is. If we've got the base knowledge, that's when you can now build onto that and create some really cool things.
Yeah. And it's actually, I had a very interesting conversation with somebody about teaching kids by giving them the instructions and having them build something from instructions versus giving them open-ended projects and letting them explore. And his view was oh, it should all be open-ended. And it's well, I think there's sort of an in-between, because some kids may not have the confidence to just dive into something open-ended. But if you do something with them first that has more instructions and then kind of let them go on their own, they'll be able to figure out from there, oh, if I did this thing, then, I can expand on that to my own thing.
Yeah, I think I taught like that most of my life, where I would teach them about the mechanism or the system, or whether it was electronics or electrical, and then gave them the problem. So they've had some base knowledge and then had to solve a problem around that, and didn't show them a solution. So then they had to find their own solution, and I think that's what you're trying to encourage, is get the children to think, but give them some guidance and some knowledge to work from. And I suppose from a school point of view, then you sort of going through what needs to be taught in terms of the knowledge, but the way you then project it can be all sorts of different ways. And I suppose that's exactly what you're showing us with your beautiful creations.
Oh, thank you. Yeah.
No, sorry, go.
Oh, I was just going to say, it's actually helpful hearing from you also how you teach, because again, I'm tutoring some students and trying to find the right balance of holding their hands a little bit at the beginning and then kind of giving them more open-ended projects without them getting overwhelmed. So it's really cool hearing how other teachers have managed that.
So can we go back to your newest one that you were showing? How did you get his mouth to move? So how do you get that circle mouth to move?
So the mouth, it's just a loop of paper, and then on the what do you call it? The rack. I just glued a little bit of. You can see I'm kind of in love with barbecue skewers.
Oh, they are so useful. They are so useful.
So it's just a barbecue and skewer glued to the rack, and then that just goes like through the loop on the thing, and when the rack goes up, the pin goes up, and the whole thing closes up and dead again.
And for me, that is so cool, because rack and pinions are so difficult for children to make. So if there's a template that can just be cut with a laser cutter, like you said, cut the card, that just takes so much trouble out of building the mechanism.
Yeah. And then you can focus on like, what do you actually do with the mechanism? And yeah, I mean, I was lucky because I don't have access to a laser cutter either. Somebody else made these and sent them to me. So that's the only downside, again, is you need a laser cutter or something else to cut them. But they're just so much fun, especially because like with standard servos, getting the, they go in a circle, and so like, or in an angle. And so getting an up-down motion can be a challenge. That's one of the other things I sort of found making these paper robots is like the trade-off between if you attach it directly to the servo, it's the easiest way to do it, and like it's probably one of the most robust, but like now you only have one servo per one movement, and if you want to so there's kind of like the more complicated the mechanism, the harder it is to make just out of paper and be robust. I was gonna say the other thing.
No,
I was just going to say the other thing with this is one thing I wanted to try, but I couldn't find was actually something more rubbery, because I thought that would be even more fun when it squishes. Because here you can kind of see like the paper creases in there, but future things to do.
Well, maybe somebody's got a bicycle tire that they're not using. What about cutting a piece of a bicycle tire?
I didn't use that, but so those, you can buy like those cheap little wheels that you use for robots, and they've got like a rubber thing on it. So I pulled that off and I was going to use that, but I didn't want to poke a hole in it, and also it wasn't yellow. So yeah.
I was just thinking with what you said about the mechanism. For me, over the years, when you build with mechanisms, the worst is that the mechanism doesn't work if it's made out of something that breaks. So like you said, if you've got a mechanism that's stable, they can concentrate on finish the product. You want the mechanism components to fit nicely and to work nicely. And so I think what you've shown there is really, really useful knowledge to share. And I think quite a few schools are looking at getting laser cutters. So also saying, you don't have to cut perspex and plastic, and you can cut sort of materials that are less expensive, which means more children can have access to it too.
Yeah, I love cutting cardboard on when I had access to a laser cutter. I love cutting cardboard on it. I made an entire chair at one point out of laser cut cardboard because I just cut in flat sections and then like slotted it all together like IKEA furniture.
Oh, that's very cool.
Yeah.
There was a question about Jasmine. You also do beautiful illustrations. Do you want to talk through your art and your illustrations?
Sure. Yeah. Thank you. That's very kind of you. Let me share my screen. Okay. Share. Aha. So that's actually here's the. Oh, sure. Yes.
Okay.
This is actually that T-Rex I was mentioning earlier.
Oh, he's gorgeous.
Oh, thank you. I will admit, like it was a bit finicky. Like it didn't want to walk in a straight line, which is funny. So,
so there's your steam. Oh, okay. I was going to say there's your steam.
Oh yeah, sorry.
You were showing us the gears.
Yeah. So this is on my website. If you go to Steam projects, and then some of them, if you scroll, you can see some of them don't have things. So like this one doesn't have instructions. It just has some like pictures of the process. But then some of the other ones, if you click on them, will take you to, so in this case, Brown Dog Gadgets sponsored this project. And so you can go there and oh, it's not uploading, but there's a PDF there.
Cool.
Yeah,
There we
and
go.
so you can just go there and print out the PDF. Whoops. And then there's just step-by-step instructions on how to make it. But, but again, like people should get creative and don't need to follow my template at all. So,
but I think even when they've just seen the idea of a template, it's given them an idea of how you can do the design, and then they could carry on from there with their own. Yeah.
Yeah, that makes it's funny because I used to do origami as a kid, and we were talking earlier about like how much you give people instructions. Like when I did origami, I didn't invent my own designs. I just followed the instructions, but like I loved doing it and I loved following those templates. And I think a lot of that kind of prepared me to make paper robots because now I'm used to working with paper. So
that's true.
Yeah, so these are some of my illustrations. I mostly do a lot of like cartoon-based stuff. That's actually like a sample book cover, not for a real book, but yeah, I really love like visual storytelling in comics. So I can't so this is the book I wrote. I didn't do this illustration. The cover, another illustrator, this incredibly talented Ebony Glenn, did all the character and like the character illustrations and the cover illustrations. But what I did do with it was actually the last chapter of the book has illustrated instructions, and so most of them I'm not allowed to share because it's not public or published, but this one I'm allowed to because we released it for Engineers Ireland. So I like drawing. So I love drawing cartoons. I also love using the art with the engineering again. As soon as this loads.
So you
Almost
say
there.
Your book's going to be out next year. Do you know when?
2022. I don't think the publisher has decided which month she's postponed it till yet.
Okay.
Yeah, it's tricky with COVID because I think a lot of books that came out, especially from new authors during COVID, like didn't do as well as they would have. So she wanted to avoid that. And I mean, I trust her. I don't know anything about publishing, and yeah. So
so we'd have to have you back next year to show us your book.
Oh, I'd love to. I'm so excited to it's pretty much a finished book. And so I'm really excited for it to be out there in the world.
These pages look amazing. They just look incredible.
So that's the other kind. I was going to say, I like using illustration to, I guess as a way to explain how to do things as well. Cause I'm a very visual person myself. And so I find it much easier to look at illustrations. And then the one other thing I thought I would show, just because it's kind of fun, is when I worked at First, I mentioned that, so I use a lot of illustrations when I'm brainstorming as well. So this was a lot of just concept art I made. And this is, I guess, more the engineering product design process of what is this thing actually going to look like? And a lot of the sketches are just really rough sketches, but that's how I kind of think about things. And that's how I go from these drawings to the art that wound up on there, which was combination of Photoshop and a bunch and photo montages and some 3D art and stuff. But yeah, I don't know. I just use illustration as a way to think as well.
Oh, Jasmine, it's been a pleasure talking to you. I've had such a fun time, and I'm hoping the people watching have as well. I've really learned a lot and loved listening to how you just think and explore. So thank you for being here. Have you got anything you'd like to share with everybody as we close?
That's a good question. Yeah, I guess just if you make the designs, the paper robots, I'm always looking for feedback on how to improve, what else I can be doing. So please let me know. Couple of great resources worth checking out is, first of all, even though I don't work there anymore, I'm still going to plug First Robotics for, I think it's a really great program for kids who are interested in robotics. And then I had mentioned Paper Mech is fantastic. Chibitronics is paper circuits. And then two other things that just come to mind in terms of introductory programming. Scratch, which I think most people know, but if you don't, it's, I think, another great creative way to like introduce coding. And then elementary.io, which uses, which kids get to program their own interactive like storybooks, which I think is really cool because I also love combining story. Like I mentioned it to like, I love combining engineering and art, but really like my trifecta is engineering, art, and storytelling. So anything that like,
beautiful.
Yeah, I love just, I mean, I love stories. I'm a big reader. So I think for me, when you combine all those things, it suddenly becomes so much more interesting to me.
So perhaps if you could drop me an email with those links, and then I'll share it with the people who subscribe. So I'll happily do that. But thanks again for this evening. I really, really have enjoyed chatting to you. So thank you for your time. I know it's late because you're in Israel. So thank you very much. But I really do appreciate it. I'm going to end the broadcast. Thanks, everybody. Thanks for your time and watching.
Thank you.